We're going to get into some details now and dive into Automate Nightguard. So for those of you who have already tried it, you might have some good questions, and I hope I can answer some of those questions here as we dive into the details. So first thing is Automate Nightguards is an open platform. It does not require you to have a dental system or an ExoCAD CAD software. It can take a DCM, an STL, a PLY, or an OBJ file from any iOS and any lab scanner that will output one of those 4 file types. So it's really exciting, really important. It is open. It is an open platform. So you take your files, they need to be in occlusion. We'll talk about that. You upload them to Automate and you get your design. So we're going to talk about design preferences. If you go to the Automate homepage, the upload page for the Nightguards, there's 4 parameters. And we're going to do a deep dive into these 4 parameters because they're really important in what they do and how they control the fit of your design and what's being accomplished. So we have offset, minimum thickness, crevice blockout, and inward retention. And here's a diagram here. We have it in our instructions for use page on Automate. So you can see this same diagram if you click on the upper right-hand corner of your Automate upload page, there's a little circle I, go to instructions for use, and you'll see this, and I'm going to explain this here. So first, minimum thickness, pretty straightforward. It's the thickness from the occlusal surface of the upper arch to the lower arch, right? How thick is that Nightguard to the opposing? And then your inward retention, how much is it grabbing under the height of contour, that retention into the undercut areas? And we'll talk about how that's actually accomplished and what that means. And then we have crevice blockout. So this is not to be confused with blockout relative to path of insertion. This is blockout that's applied to, you can see right here, it's in the central groove or the central fossa. And then we also apply blockout interproximally as well. This is an awesome feature that allows for easy seating on first time. The labs that we're talking to, when you dial these preferences in, you should be able to print, post-process your Nightguard and fit it to your model with little to no internal fit adjustments. It should just fit perfectly right out of the printer. And then the offset, that is, of course, just the space between the Nightguard and the teeth. So we're going to do a little bit deeper into minimum thickness. This is really awesome how we achieve this, and we're taking the bite relationship into consideration. So you upload your scans, upper and lower scan need to be present in occlusion. And then what we do is the automated intelligence orients the jaw scans like a virtual articulator would, right? We establish a TMJ relationship to the arch. And then what we do is we open the bite relative to the minimum thickness that you requested. So we open the bite in a hinge like movement, and then we determine the tightest area of the bite. It's most often the lingual cusp of the second molar. And then that tightest area of the bite is honored as your minimum thickness, but then you're going to be thicker around the arch and into the anteriors as the bite has opened. So it'll result in a nice uniform occlusion to the opposing. This is a QC screenshot. So this is after the design's done for you. You will see here in the parenthesis, that's what I ordered. And then here you can see that little circle represents a sampling that I got a Nightguard that's 1.41 millimeters thick, but I ordered 1.5. So you can see here we missed it by 0.09. So if that bothers you, you can re-drag and drop it at slightly thicker, or you can say, you know what, this looks pretty good. I think I'm going to go with it, right? So that we give you that confidence that what we designed for you is good, and you get to make that determination before you decide to download and pay for it. So inward retention, we're going to dive into this a little more. So basically, we survey the model, we apply blockout under the height of contour, and this is, it's the largest allowed undercut as measured perpendicular to the insertion axis from the widest point above the undercut towards the tooth surface and in the undercut region. I know that's kind of a mouthful, but basically it's, you've got your blockout coming down, and then you've got this inward retention where it says that green area is what's removed. So if you had your inward retention set to 0, then no blockout below the height of contour is removed. So it's going to be much more passive. in that area. If you want it to be more retentive, you would add some material to be removed. So it'd be, in this case, if I said 0.1 millimeter, so that I'm going to take the block out below the height of contour and remove it perpendicularly inward to achieve that retention. We call it like it's clamping underneath the height of contour. All right, and then this QC image here, you can kind of barely see them, but it's looking into the intaglio surface of the Nightguard. We show you this before you download and pay for your design. You'll see these areas of magenta, which is to show you here's the area where the Nightguard is engaging into the undercut. So if you see a lot of magenta, it's going to be very retentive. And if you were printing a key splint hard, maybe you should be concerned about that, right? You don't want it to have too much retention with the hard material, because then it's going to be very difficult to go in and out. But again, it's dependent upon the materials you use and your printer settings and all of that kind of stuff. So crevice blockout, this is virtual wax filling to block out grooves in interproximal regions. So we have a few different settings. The minimum setting is very light. So we're going to take 100 to 150 microns of blockout and apply it to the central groove, central fossa, interproximal spaces like you see here in green, all the way up to very heavy, where there'd be up to 750 to 800 microns of blockout applied. So you can see here visually, this is what helps make sure that that appliance fits nice and passive, but you're going to get your retention from your other settings, but then you're not going to be hung up interproximally if you have these small slivers of material trying to fit in there. So it's a really cool setting that we have for Automate Nightguard. So an important point that we're going to hone in on is the bite must be in centric occlusion when you upload it. And we're going to show what that means, right? You got a bite, it's in centric occlusion. When you upload that case, we actually show you, here's your bite as you scanned it, and we'll even show you, here's the occlusal contact points of your bite as it's interdigitated. So this gives you a visual confirmation that your bite is in occlusion. And then when you see that, now I see in this upper left screenshot up here, this shot here shows me that's the Nightguard against my opposing arch. So I can see nice, even, uniform occlusal contact to the lower, which is awesome, right? So this Nightguard should, if the internal fit is good, which it should be if you've dialed in your settings, this is really going to have amazing uniform occlusal contact around the arch. It's going to fit great, function great. It's going to be comfortable to wear. And so when you see this, you should be like 2 thumbs up, rock and roll, ready to print. But what if the bite is open? What if you upload a case like this? What happens? Well, we're still going to design a Nightguard for you. What you're going to see, though, is your bite scan is opened, which you should pay attention to that. And then in the upper left, you see, well, there's no occlusal contacts. Well, we still designed a Nightguard. You could still use it. You could still fit it to your model, but you might have to make some fit adjustments against the opposing to make sure that fits okay. But there's an easier way to solve it, is you could take the case into, so how do we fix this? Take the case into Dental System. You could articulate your bite, save your bite, upload the case back to Automate, and this is that same case. We articulated it, re-uploaded it, and we could see we solved the problem here. We have a nice even occlusion because we adjusted the bite or closed the bite in Dental System. So if your doctor is taking scans and the bite's slightly open, that will affect the fit. So you definitely want to make sure it's interdigitated and that your bite is in full occlusion, as that'll affect the fit and function of the Nightguard straight out of the printer. And so this is what you want to see, blue contacts around the arch, so you have some nice even occlusion. This is a live Automate Nightguard case printed with Key Splint Soft on the carbon printer from Kayla Nakanishi. She's been fantastic to work with. And what she tells us is that the Automate Nightguard it's easy to customize for the perfect fit with little to no adjustments. And she loves the consistency of the design and the ability to scale as many as she needs for that day. So I think that's really, really exciting. They're blowing it up with Key Splint material, and they're super, super excited. So I'm going to hand it over to Cole. And something about Automate Nightguard is it's not perfect every time, right? When you upload a case, you are interacting with an AI algorithm, and sometimes it gets it wrong. And I would say this is why we need a dental technician, is to handle some of these edge cases and make sure that it's doing a good job. So Cole, I'm going to have you just talk through how missing teeth are handled with Automate.
Sure, yeah. So as Rob mentioned, there's going to be occasions where every once in a while you'll come across a case where it's just not ideal for how it was submitted. So one thing I like to kind of point out with this is if you have a case where you have a missing tooth, for example, Automate is going to still design that night guard. However, it's important to know that there's a chance that there could be a little bit of issues with the undercut area. So if you have some neighboring teeth that kind of dive in towards the gingiva, there's a chance that you can see here on the image on the right that it could possibly hang up. So although it's gonna complete the design and it does a pretty good job, there may be some adjusting that's needed in that area just to get that to seat properly. So what I like to recommend for this is if you do not want to have to, adjust that with a hand piece, you could always just throw a quick wax up in there and scan that, and then you can eliminate that issue altogether. In cases with missing teeth, as you see here, it's just, I would, like I said before, I think it's either way, it's kind of just depends on how you want to handle the case. But for the most part, as long as you have, something to block out that area, it shouldn't have any issues with seating. Another issue that we kind of run into every once in a while is you can see with this scan, we have a little bit of extra stone right here on the palate. And what happens with that, and you got to remember we're dealing with AI, so it's not perfect, as Rob mentioned. So on occasion, you'll get a crazy outcome like you see here, where it almost looks like some type of RPD design. So what happened here is Automate read that scan and it almost annotated that there was a tooth in there in the middle. So it tried to close that gap and kind of create a transition all the way across the palate there. So the easiest way to avoid something like this is, I would say, always, before you submit the case, maybe take a look at the scan. If there's something that you can remove on it, that's going to be easier to do. I mean, you can also do it inside of Dental System. So what I did with this particular order is I brought it into Dental System and just set it up as a standard crown, and I just edited the scan myself. So what I did is I just band-aided that little area on the palate there, and then I saved those scans and then just imported them right back to Automate. And you can see here with the outcome on that is it just made you a perfect design just like that. But again, I think overall, it's probably easier to handle those type of situations if it's a stone model in the lab with a hand piece. Just make sure you have a nice clean scan. We do see this on occasion where if there's like a little tail on the posterior of the last molar, maybe just knock that off a little bit prior to uploading and you should have no problem with it.
Awesome, Cole. Thank you. And you guys here on the webinar today, we're here to support you. So if you have any cases like this that kind of go crazy, we'd love for you to email us the scan, email us the screenshots, and we'll dive into it, go into root cause and see what happened and how we can solve those issues. So that's pretty much it for Automate Nightguard. Super excited to share all that with you.